bases are?
Nope.
Now we're going to teach them with our posters. Stick around to learn more.
Baseball.
I'm Jaylyn.
And I'm Savannah.
I'm Paige. And I'm Ashley.
And we're here to teach you about
Acids and bases. And sums. Hey guys, welcome to Acids and Bases. Now there are many different types of acids and bases that you can find in everyday life. There are, for acids, you can use vinegar, oranges, soft drinks, or battery acids. Now don't touch some of them because they will burn you. But not only acids burn you, bases can burn you, such as bleach, laundry detergent, soap, and baking soda.
There are also properties of acids and bases, such as the taste, touch, reaction to metals, electrical conductivity, and the indicator. So, for acids, the taste is like sour, like a citrus fruit, and for bases, kind of bitter, like soap. Touch, acids are kind of like water, like, and bases are like slippery, again, like slope. Soaps are, drew a little wet floor sign. And reaction to metal, acids react big. And bases don't always react. They react to some metals, but not usually. And electrical conductivity, they're both electrolytes, and they conduct well. And an indicator turns color in an acid solution, and another color in a base solution. And litmus, is that how you say it? Yep. That is an indicator for both acids and bases. In an acid, it turns from blue to red, and in a base, red to blue.
Hello, I'm here to talk to you guys about a neutralization reaction. A neutralization reaction occurs when the proper amounts of an acid and base are combined, and the product of this reaction is water and salt. Now, I'm not talking about sodium, table salt. I am talking about an ionic compound, salt.
We're talking about Arrhenius' definition. So an acid dissociates in water and it produces hydrogen, but bases dissociate in water and produce hydroxide. Some examples are of acids, we have hydrochloric acid and nitric acid. And for bases, we have calcium hydroxide and ammonium hydroxide.
He's learning.
I'm learning.
The Bronsted-Lowry definition says that an acid donates an H+ ion while a base accepts an H+ ion. You can see that in this equation right here. There's not a hydrogen connected to this oxygen, whereas on this side, it is. There you go.
In acids and bases, there are two main definitions of how you would describe them. There's the Arrhenius theory and the Bronsted-Lowry theory. In the Arrhenius theory, they say the acids produce H+ ions and the base produce OH. And in Bronsted-Lowry, acids donate H+, and the bases accept H+. And there's also the question, is one better? Which theory is more reliable? And the Bronsted-Lowry theory builds onto the Arrhenius definition, and so it adds more detail and less confusion in acids and bases.
Now we're going to talk about the conjugates. We're going to talk about first conjugate acids, and that is formed when you have a base and you add a hydrogen ion, and then in turn the conjugate base is what is left over after you take a proton away from an acid.
Okay, so some strong acids are hydrochloric acid, nitric acid, and hydrobromic acid, and some weak acids are sulfuric acid, nitric acid, and hydrofluoric acid. And if you have a strong acid, it's going to have a weak conjugate acid-base pair, and then vice versa.
So
Ryan and Blake know all about
the acids and bases, don't you guys?
Yes.
Yep.
Oh, good.
Ryan and Blake agree.
Now Austin knows all about acids and bases, don't ya?
Yes.
Yeah! Okay, boys, now do you know everything about acids and bases?
Yes.
Yes.
We know
Yes.
more than everything.
Oh,
Good!
sweet.
Awesome!
We learned about the Bronsted-Lowry definition, strong acids and weak acids, conjugate acids and bases, and the Arrhenius definition, properties of acids and bases, and neutralization, and examples.
Yep.